You're listening to Cultivation Elevated, hosted by Michael Williamson and Anders Peterson, where we discuss vertical farming and the future of cannabis and food production.
Hey, what's going on, everyone? From Pipp Horticulture, I'm Michael Williamson, along with Anders Peterson, and you are listening to Cultivation Elevated. Today, we're joined by Mike Zartarian, an electrical and CEA design engineer and the principal at Zartarian Engineering and Precision Ag, based in Watertown, Massachusetts. Mike has 20 years of experience as a design engineer and systems architect across multiple industries and has spent the last decade focusing on controlled environment agriculture. Mike, thanks for joining us today.
Good to be here. Thanks for having me.
Yeah, and for the listeners, a little background. All three of us have kind of met organically, just working on indoor cultivation, design projects across various companies. And probably over the last 3 or 4 years, we've run into each other on, a couple dozen projects here and there. And we've all become kind of good friends. We see each other at conferences a lot. We've spoken on panels together. I've always really enjoyed my conversations with Mike, and I'm happy to have him here. So thanks for joining us today.
Yeah, thanks, Anders. It's good to, we've seen each other for years at every conference. You guys are a staple there. I always look for you.
Yeah, and I think what's interesting about you, Mike, too, is you're an electrical engineer, I think by training, but you're also quite the horticulturalist. And when people hear engineer, they kind of generalize the term, but you're truly a plant person too. I mean, you know plants inside and out, but beyond that, you also know the engineering that goes into controlled environment agriculture, and that's what's always kind of set you apart in my mind. And that's what I'd love to kind of dig into today. And so, if you don't mind, I know a lot of your work at Zartarian Engineering is sort of commissioning of facilities. I know you do design work as well. But if anything, can you give us an overview of what you do at Zartarian Engineering, and then we can dive into some more of the questions?
Yeah, totally. So the I guess some of the background of like how I ended up doing this is that, I grew up around plants in a farming community. I never thought that I would be like doing agriculture as a career. I went to engineering school. I did stuff there. After that, I was a design engineer, product design at Bose. I eventually like saw sort of the end to that industry, if you will, and moved over. And once I started doing ag stuff, was designing like equipment, LED, like early LED fixtures, sensors, that sort of thing. And we quickly saw that we needed design of full facilities, like holistic design, because I had a grower myself of cannabis and other and all plants. So that's sort of where we go anywhere where holistic design is needed, and that is at the initial design as well as commissioning and facility startup, and then ongoing operational support. Again, on the technical side, usually like of a good if it's strictly like a root zone feed issue, like there are others that are better. But almost always it's something to do with the full facility. I call it the plant life support system that is the facility. The facility is, I view the whole thing as a machine, and we kind of specialize in working on designing and working on that machine and getting it to run correctly to support what the cultivators are trying to do instead of the cultivators fighting against it.
And did you start Zartarian Engineering right when you left Bose, or how did that come about? And how'd you kind of link up with your partner, Mike Siegel?
Yeah, so Mike and I met at Bose. We designed products together. We're both musicians. Mike is a professional touring musician. I've been that in the past. So we then moved away from Bose and actually designed an aquaponics home system at a company called Grove Labs for a couple of years. And that really got me into the, LED design, sensor tech, all of that. I was leading a team of 13 people designing that product. Super fun. And then after that ended, I worked as the head engineer or facilities engineer at a lettuce farm here in the Boston area that was fully indoor. At that time, we had some like rooms and a lot of containers. So it was, talk about a crash course at that time, and like having all those different systems and HVAC systems to deal with. And it was great for experimentation because we had 15 identical rooms basically to deal with. So I worked at that company for a while. Their funding was unstable, we'll call it. And so I had to, I left there, but then saw, wow, there's so much opportunity sort of across the industry. And then from there, I was working with indoor veggie producers. And then as cannabis came to the East Coast, switched over into helping that side of the industry out.
Yeah, we actually met. I don't know if you remember this. The first project we met on was an indoor leafy green project. Um,
Oh, right. Yeah.
yeah, and then since then we've worked on a number of cannabis facilities too together, or at least kind of collaborated with ideas. But yeah, that's I find it interesting. You started with lettuce and kind of moved into cannabis, and it's usually the other way around for a lot of the people we talk to.
It's interesting because the two sides of the industry don't really acknowledge each other's existence. You kind of go back and forth, and like the vegetable people do not want to hear about cannabis, and the cannabis people are more open, but don't want to hear about, lettuce, leafy green, vegetable production. So yeah, it's interesting. You could exist in both worlds and no one even knows that you work on the other.
Yeah.
They're all plants. The process is it's very similar. Both are special, but but they're very similar.
One of the things I have heard from the leafy green folks, and this is more recent, but they were like, because of the cannabis industry driving so much innovation and then inevitably more competitive costing with vendors focusing on solutions there, that it's made certain solutions more viable for them as leafy green growers. Like Pipp has several leafy green growers, but predominantly we're driven by the cannabis industry. But because the demand was so high, that it created cost-effective solutions for leafies as well, which I thought was kind of interesting. I never really thought about it quite that way.
It certainly has helped a lot, like in the early days, before cannabis, trying to find an HVAC system that could do any sort of indoor ag application was uh, pretty much impossible, pretty scary. Like you were heavily modifying whatever you were buying, for large facilities. So it was a leap of faith and a lot of busted equipment and mistakes on that, on that side. But yeah, they benefited mightily from it, such that those operations can scale down a bit to to cannabis sizes and not be, they don't have to be so big to be profitable or to be competitive.
Would you agree that from an engineering perspective, out of all the crops you've worked across indoors, cannabis is worst case?
Oh yeah. Yeah. It's the most energy dense, as in like you have the most light as your, coming in as your energy input. So therefore you have plants that are transpiring the most. And then you add in all the special conditions of day lengths, sensitivity, what you need to do to drive quality. The bullseye to hit is much smaller than it is in like lettuce production. Even some of the other fruiting crops like tomatoes or peppers, there's a wider range in those crops as opposed to cannabis, very specific. And the cannabis is excellent at being very disease prone. It's a fragile plant during its last several weeks compared to anything else that I work with.
Hmm, that's interesting perspective. So going through the design process, a facility design, what role do you typically take in that project? What do you like? Like, what's your interests in the facility design? Where's kind of your niche there?
Yeah, we have a strange niche in that I like to do all of it in that holistic farm design. So try to start like working with the business, the grower, or whoever owner, and kind of say like, what are you trying to do? Because there's so many. I mean, we talk about this, at conferences all the time. There's so many ways to grow the plant, and they all can be successful depending on what your end product is. Are you trying to grow uh, quantity, lowest production cost? Are you a craft facility trying to grow, 12-week sativas because that's what your local market needs? Are you going for extraction? What type of extraction? Are you going for a water-based hat? All those things. Take that and design the facility from the plant out because those, you know, your goals are going to determine like what is the best stature of plant to grow. You're going to be growing larger plants, smaller plants. Are we in rock wool, living soil, cocoa, something else? and kind of design the room sizes and the horticultural process around, what you're trying to achieve. Like you're going to want, for example, like craft producer is going to want more time to turn a room over, generally larger plants than a high volume producer who's going to have, a larger crew, faster turnover. So I really like getting in to be able to design that, like details of the horticultural process from the plant out, and then matching all of the equipment, uh, LEDs, racking, HVAC, uh, sensors, all that to, control system to that. So just selecting, the right tools for that particular job, because there's so many choices, right? And it
So
doesn't
many.
work to just mash a bunch of random stuff together.
I liked that. I've heard you describe yourself as a horticultural process engineer, and I think that's the first time I've heard it worded that way, but I thought it described you kind of perfectly when you said it.
Yeah, it feels like a big gap because it's such a growing plants is such a, I guess, a holistic process, and everyone in, you know, kind of like facility construction comes at it with kind of their own specialty, their own hammer, and everything looks like their nail in the project. And yeah, we try to parse that out, and I really try to concentrate on like the end goal and serving that end goal is as best as can be, set up at the jump. But yeah, really like I love the plant. I also really enjoy working with people who are passionate about growing it. So guiding them from getting from like this idea where they have like a strains and a process that they like in, at small scale, at, 4 lights, but then scaling that up so they can be successful at that at hundreds of lights it's a lot of fun for me.
So, one topic I would like to touch on, and to kind of give the listeners a little background, this concept of commissioning a new facility, or tuning a new facility. It's something we've talked about at length over the years. For listeners, commissioning stems from shipbuilding, where they would commission a new ship to make sure it was seaworthy, essentially. And that process has carried over into design, build, architecture, engineering, and building construction. It's a process typically done by a third party, not someone in the construction hierarchy. And they essentially go through their building and make sure it's operating as it's been designed. And then even furthermore, there's some kind of specific tuning tasks that can be done in these cultivation buildings to really dial in your control system and all of your equipment to function and kind of fit your building the right way. Mike, you're one of the few people I know who really offer that service and really do a good job at it. Someone I would trust to commission a building and tune a facility. I see so many facilities skip that step and have a rush to move plants into the building because it's understandable. People have taken a long time to build these buildings. They want to get to revenue generation as soon as possible, and they move plants in instead of taking the, you know, 10 days to 2 weeks to do some commissioning steps prior to moving plants in, and then commissioning as you move plants in and tuning. But instead, they skip that, and it ends up costing a lot of people a lot of money if they had just taken the time to do it up front. Can you tell me a little bit about that process and kind of how you got into it, how you approach it, things you look for?
Yeah, totally. I mean, it's such a hot topic for me because that's like you spend, I don't know, $25 million on a facility, and then any other $25 million facility in any other industry has like a long ramp up period where they don't just like stamp on the gas and go, right? And put it under 100% occupancy or whatever process they're doing there immediately.
Yeah.
Uh, I got into it out of necessity while working with folks and seeing like, yeah, basically coming in and doing what's called retro commissioning, which is they've been operational for 6 months and are struggling. And that's how we got into it, is like, oh, like 70% of the facility is working correctly, and there's just stuff everywhere it doesn't work. And it got it, and then basically saying, as we worked with more and more folks, like, hey, we really need to start up this facility in a specific way. So on larger systems, it's different for larger facilities and smaller facilities. On larger systems, there will be somebody who does like a commissioning agent in the standard industrial sense, which they'll like balance the HVAC system, not specifically for plants, but just getting it to run to spec. And same thing for, sometimes fertigation systems comes with somebody from that company and they get their system working to spec. Same with controls. Lights are fairly basic in that sense, but each of the systems will come with it. But to get them to work together and actually work to grow plants, there's nobody who does that. And that's what we went in and do. So it's getting that system and making sure like all the small pieces work together. So one of the things that we do is to confirm that the system is working well. Usually most of the work is in the environment and figuring out the environment and the HVAC system. So like getting the rooms correctly, not only like balanced from an HVAC point of view, like is the right amount of air blowing out of this duct, but we put like, for example, put sensors all around the room and say, is the temperature even all around this room? Is the VPD in this 1,000 square foot room or bigger, like, is it the same? Because the first thing, if you want to do any sort of get any sort of consistency in production, you need the plant conditions to be the same across the whole room. Like that's like the part of like crop steering or plant empowerment that I feel like is missed in indoor ag, which is that if you want to do, you can do all those tactics work awesome on one plant, right? But you want that one plant or multiple plants that you have your sensor array on to represent that whole room. So really getting in there and making sure that, that life support system is consistent and works and and I think the biggest barrier to achieving that, as you were hinting at it, is not counting on loading in everything right away, because it is, I would say, 5 times as expensive and to fix anything once there are plants in the building, as opposed to before there are plants in the building. So we really recommend, like we do a pretty thorough pre-op checklist. We try to load the system with water vapor by like putting humidifiers in rooms, really taking the lights through their paces, putting energy into these spaces and running them as best we can before plants are in there. And all this takes time. It doesn't take that much time. It takes a couple weeks to do a really thorough job. But 2 weeks at the end of a project when everyone wants to load in is just, it seems like forever, but it's not that long when you consider how much money you lose in crop loss and failures when you have a system that doesn't work. So we've, in that 2-week period, we're finding things that are wrong, and then getting the contractors of the various systems who are still there to fix it. And then, then and only then we kind of like encourage folks to load plants in, usually at a slower pace than they would otherwise. Say like you have a facility that wants to run a 63-day flower cycle, and maybe they reset every 63 days. We try to get in there and say, hey, why don't we start at 80? And we delay, and then we can speed up that cycle, like pick up a couple days as we go through the first 3 crop cycles. And that gives us time to fix things in between cycles. And that's what it usually takes. It takes us about 3 cycles to get everything, every room to 100, to 100%. Everything's working. We have checked everything off. And now we have like a baseline of operation, which says, hey, if something's not looking right, it was working at one point, and this is what it did. This is how the system performed. You can get within plus minus a tenth the point of BPD across this whole room, when it's working right. And I think that also is critical for being able to get your system fixed later on down the line, because all the vendors, it's easy for them to throw their hands up in the air and say, well, looks like it's performing fine to us, but it could be, causing stuff to die, or there's powdery mildew everywhere because there's poor humidity control. I could go on and on. This is like the most critical thing. Like I can't
Yeah.
believe people skip it. It's just
No.
millions of dollars are lost.
Yeah, I can name a number of examples. I had a project in Oakland where they moved plants in right away, and it cost them millions of dollars over the first 18 months to essentially retro commission while operational on their, mechanical systems, but also all of their fertigation and controls. I mean, it cost them millions of dollars in crop loss, and contractors having to come back and forth and just calls. And it added up significantly. Michael and I know you're similar, Michael, in terms that you like to kind of partially load facilities and ramp up production in a way too. And we were at a facility recently where that was happening, and they had skipped some commissioning steps, and we saw it even in the graphs. Remember that? We said every 3 hours, some valve or something is cycling because we can clearly see it on the graph, on the trend lines, that there is a controls issue reoccurring on the dot every 3 hours. And we talked about how commissioning and tuning could, eliminate these kind of issues and challenges that they're now dealing with every 3 hours on the dot.
Yep,
You
that
answered
sounds
one of my
super familiar.
questions, which is, obviously it's really hard to commission a room without plants, because you need that, that energy load. And so your solution, I think in your own words, as best you can, of course, is you're dumping in humidification to emulate the natural transpiration of what would be a loaded room. I find that to always be challenging. Um, Even before all that, it's like, all right, so you're bringing in plants, depending on that immaculate conception period in that state or that country. Bringing in plants could mean bringing in thousands of plants from somewhere off site, or bringing in like a couple clone domes. And so, but most people end up with usually not a lot of plants to start with. And so they're trying to turn on these systems, and there's just physically like not enough biomass in the room. And so everything isn't operating kind of as it should. And so I think a lot of people need to be thinking about that too. Like, all right, we're not bringing in a whole lot of biomass. Like, we need to supplement our humidification while we're ramping up and getting our plant production up. One of the things that, I don't know, commissioning is such a unspoken thing. It's so sad. But like you said, in every other industry, especially when you're spending tens of millions of dollars, commissioning is just, it is part of the protocol. I would say almost every single project is. I very rarely come across a project that's like, yep, everything's on target as far as timeline goes. I'd say your average project is delayed from when they initially thought they were going to be breaking ground, usually about a year, sometimes longer, sometimes years. And so you have this multifaceted compression of, well, we didn't budget that much cash. We budgeted cash for this much time. Now it's taken us an extra year that we didn't budget for. So we've burned through some things. And so you get this, and I've been in that position where you're in that, you might be a cultivation manager, you might be a director of operations, and your board, your investors, or a combination of all of the above, or your C-suite team is really pressuring you to get plants in the building. And so, in their mind, they don't understand why plants just can't enter the building the next day upon certificate of occupancy, and how come all the rooms aren't fully loaded. They just don't understand the plant process, but they also don't understand, well, what is that? How's that going to impact our system? How are we going to start these systems? How do all these things integrate harmoniously together? And none of it's ever perfect. But I'm getting to a question. Sorry. My question is, so if you're commissioning a space, but you didn't design the space, you're at the risk of saying, hey, we've done all the diligence work here. We've commissioned systems in best of their capabilities. But then I'm sure you've had to have the conversation where you say, unfortunately, it appears that whoever did the load calculations on this, or spec this system, or installed this system, it's undersized, it's oversized, it was installed incorrectly. What does that look like when you have to kind of deliver that kind of message to a client who's just spent, like you said, $25 million in years of their life to find out that, we missed the mark? The original engineers or whoever it might have been on the design team missed the mark on kind of what was required from a system standpoint.
Yeah, that's the least fun part of any project that we're involved in, because it happens a lot. Um, And on bad projects, it's usually where we get kind of like shown the door because that's the type of bad news that nobody nobody wants to hear, and they just forge ahead, right? But I think that in the best scenarios, it's like, all right, let's come up with an action plan, which is like, what can, and I think the best ownership groups say, all right, so what can we do? And I think that that's the key is that, even with 75%, let's say 75% of the anticipated production, 75% of really good quality biomass is better than 100% of not, of stuff that needs to be remediated or is low quality because of, and also that to get that extra 25%, I think most cultivators know intuitively, like it takes a lot more labor, multiple times more labor to tend after a sick crop than it does after a healthy crop. And that's kind of what we put forward there is saying like, hey, like this is, you'll do better running at 75%. And that is, I haven't figured out if you have any good ways to tell that to a non-plant grower, you please let me know because I haven't figured out how to tell that to an investment team. Yeah, because yeah, I try to say like these are plants, they're living things. They do not care about your schedule or your financial projections. They do not care. And I haven't been in a situation where like fixing the HVAC system, which is usually the problem. It
Yeah.
makes where that makes financial sense. Usually, it is what it is, and yeah, we need to just go with it and figure out how to work with what we have.
Yeah, I like that advice. I think it's honest and it's true. And Anders and I have been working on a way to communicate that better to people. I think when you look at like investor class, they're most responsive to numbers and data. And so, like on one of our last webinars, Anders and I did, it was optimization versus maximization, and optimization taking more of a holistic approach to your design approach, making sure that you're taking into things consideration like airflow, supply and return locations, workflow, things like that. But it's typically less total canopy. You're still trying to maximize canopy but within a realistic reason, and not just shove a light somewhere because you can squeeze a light in, or make a row a little bit longer, and that the workflow is going to be a little tighter, but they'll figure it out, kind of thing. And so what we're able to find out is that most people that design with that optimization in mind, they're actually, well, their capex is lower because it's less lights, less equipment. But we're typically seeing that those are operators that can hit 80 plus grams a square foot in some cases, where the ones that tend to just cram as much canopy, tray, however you want to call that, into a room as physically, humanly possible, they're the ones that get stuck kind of in that 39 to maybe 55 grams a square foot. And then they come back and say like, we need help and we got to get there. And, we start saying things like, we'll pull out a whole row of these lights in this rack and that tray, open up this space. And, it's just like, you can see their eyes cross over because they're like, how do you expect me to get more canopy when you're going to take canopy away? But it goes to the point that you said, if your system is capable of, let's say, 75% of what you design, then focus on that 75% and then make some money. And then maybe you can make the changes to get yourself back up to 100% versus that long multi-year road of frustration of failed microbial tests. And, the one thing that people don't talk about enough is, sure, beyond getting remediated, extra cost, extra touch points, more trichrome degradation just from touch points alone, and maybe you have to ship it off site somewhere and ship it back. Retesting, that's always more expensive. But what people don't talk about enough is like when you have a sick crop consistently, your employee morale drops to like the floor. And when morale drops with your employees and your staff, your efficiencies drop quite a bit too, because like how excited and how motivated and how eager are you to defoliate a plant that's covered in powdery mildew versus one that's not?
Oh yeah, it's tough to watch too because I think a lot of times I come in and I am immediately defending an embattled head grower from getting fired because he's being held accountable for being growing in a in a system that's not fully operational. And you'll see these, I call it struggle city, like when one of these facilities like never starts correctly. And it's like 18 months of just dawdling along and like four-head growers, and it just gets a bad reputation, and like you can smell the mold in the parking lot.
Mhm.
Yeah, it's that's I don't people only seem to be operators only seem to be open to like that idea of less is more and kind of like smooth is fast once they've experienced that. I think that in, 10 years, once this is like an established industrial process, if you will, it will act like more other industries where, we're looking at building these facilities with a 10 or 20-year time horizon. And then it makes a lot more sense to spend a month to start it up correctly. But yeah, while we're still in the Wild West, it's tough to justify. It's really tough to deal with a facility that has like 8 different flower rooms. That's probably the biggest. I gloss over it, like in what I was saying earlier. Like, make everything the same. Like this is a nice, repeatable, smooth process. Like,
In eight
when you
different
build.
flower rooms, you mean 8 different sized flower rooms, not a
Oh yeah,
homogeneous room design. Yeah, I agree with that. That's
yeah,
tough.
one with like different shape, even if they're the same canopy square footage, like it's a retrofit, and to fit more plants in there, there's been, this one has like an L on it, and this one has there's some, I always joke, it's like when you see the plants that put like their plants in like broom closets and stuff, it's not, yeah, it's not good. You guys probably encounter the same thing where on people's, applications and whatnot, there are these ratios that exist in sort of like the legal land of like, oh, the facility should have this percentage of flower, and there should be this percentage of veg to flower canopy square feet and whatnot. And all of those, for the most part, that float around in investment circles are too high. Like if you actually build a facility with those ratios, like you're going to end up making dissimilar rooms, and you're going to hamper that process, and yeah,
Bottleneck
less.
usually.
Yeah,
Yeah.
right. One of those rooms is going to be bigger than all the others, and it's going to set the process sort of like, uh, it'll just make it inefficient and not run smoothly. And then the labor costs go up, and that's the killer, is when labor costs skyrocket.
It's
Mhm.
one of those like design things where when you look at someone's initial drawings, you kind of know immediately whether they know what they're doing or not, and we see everything over at Pipp that gets submitted. I mean, we see all kinds of different creative ideas and some creative but really illogical ideas. I've seen clone rooms exactly the same size as mother rooms, where I was like, this clone room could support like 10 of these facilities. No bedroom or a tiny bedroom, bottlenecking flower all the time, no drying room. I mean, you see the same common trends and then you just see some out of the box stuff. But yeah, it's unfortunate that a lot of operators have to go to a point of pain to start to open their eyes into kind of what needs to actually happen. And, it is unfortunate with especially not first time growers, but the first grower at a facility. We have an internal saying over at Catalyst is the first grower usually never makes it. And it's not the grower's fault half the time. It's the fact that they're being held accountable for engineering, design, equipment selection, lack of integration that they really had either they were involved with and they shouldn't have been involved with because they weren't qualified, at least not to be the sole person making these decisions, or they weren't involved with them at all. But I think that's a lot where you guys come in, and it's really cool that you guys can bring in your own sensors, these redundant sensors,
Yeah.
and validate this stuff. A lot of people, when I talk to new cultivators and on larger facilities, at some point I have to have a conversation with them and I say, do you want to manage people or do you want to manage systems? Because at this scale, you're not going to be able to do both at the level that this company needs you to. And so we look at their interpersonal behavioral traits and where their strengths are. And a lot of times I'll delineate that responsibility between two people. Like you're in charge of systems and you're helping support team when you're not doing that. But, and then I have usually someone that's like, you're the one that's motivating people, making sure tasks happen. There's a little bit of crossover, but just because managing systems in today's era of cultivation, it's a full-time job. And you're doing these micro tweaks often in terms of sometimes environment, but for sure irrigation and a lot of other little things as well. So yeah, it's just interesting how the role of the grower really is so much more than just plants at this point.
So much more. I mean, this industry, like the cannabis industry of, up until now, puts more responsibility on a grower than any other agricultural industry. Like even in the, like going back to like the lettuce side, no grower is held accountable in a large greenhouse for how the HVAC system operates. That's, here it's like they have all the same responsibilities if they were running like a legacy market for lighter.
Sure.
And yeah, it's like it's a little bit more complicated than that, as you're saying. Yeah, and I'm big on grower teams. Like you have the one grower who's more technical, who's behind the laptop tweaking things, and then you have the one who runs the grow tech teams and like does the scheduling, does the people, yeah, hiring and firing and people motivation and improvement. Yeah, one person does not have the brain space to be able, or personality. Like those two roles are fundamentally different strengths. And every facility of any size, more than like a couple thousand square feet needs both of those things.
Yeah, I couldn't agree more. Um, yeah, those two personalities are very different. Like it's funny. That's I think why Michael and I get along so well at Pipp is I'm very much a guy on the laptop looking at data. I like managing systems, and he is a wizard at managing people. And I think that's why we've meshed so well. Is I mean, he's good at both, right? But he's much better at managing teams and labor efficiency, and I like nerding out on graphs and data. It's pretty funny. Speaking of graphs and data and nerding out, I know you and I have talked in the past a little bit. When you go about trying to dial in an environment, and let's say, a multi-tier facility, two-level flower, and they have an existing control system with sensors in there, uh, be it one of the major control companies for whatever. Um, do you still go in with your own sensor suite and install them side by side to kind of do your retro commissioning and then compare that
Yes.
data? Can you walk us through kind of how that happens, how it works?
Totally. So this is again born out of necessity. Um, we found in the industry that basically all the sensors that we would encounter installed in spaces were not accurate. So that we ended up having to have these like crazy tables of like, well, at during the day, this sensor reads 5 degrees higher. So therefore the HVAC system needs to be set to this to get the plant to get the leaf temperature to where we want it to be. It is terrible.
Well,
So
sorry for interrupting you, but real
yeah, yeah,
quickly, is the inaccuracy due to the placement of the sensor in these pretty harsh environments under lights, near fans, etc., or is it the actual technology and the different sensors?
it's both. I think in the earlier days we saw a lot of like residential thermostats like placed on the wall of on the wall of the grow room, and that's not going to work. I think most are onto that at this point. And then yeah, it's the sensors. Okay, yeah, I
Not
know,
all of
right?
them. Yeah.
Not all of them,
I
but at
witnessed
least that.
something recently, and I saw 20 honeywells in a single room, and I was like,
Oh.
wow. Go on. Sorry, but yeah, people are getting away from it more and more, but not enough.
Yeah, and this, the place for the sensors, in my opinion, is at the plant canopy, right there, so that they're sensing what the plants are sensing. And no sensors we've encountered out in the field that do that really well. Like they exist and are accurate under, 12, 14, 1600 ppfd right at the plant canopy. And the primary thing that happens is that they get heated by the lights, and that ups the temperature of the sensor and lowers the humidity. So you end up getting a higher temperature, lower humidity than actual, which drives the HVAC system to do the opposite because
Yeah,
it
cooling over
thinks it's hot.
dehumidification.
That's right. And that is, believe it or not, like there are a lot of capable systems out there that get blamed for being not big enough because they are being fed poor information. So what we do is the first thing we do is we build our own sensors that, are wireless. These ones are for like research and retro commissioning. They're wireless, so we can jump over whatever network there is. We just install our own, gateway and network. Um, and we put them at a much higher density. So we'll put, in a 3,000 canopy square foot room, we'll put 8, 10, 12 of them in a multi-tiered environment, distributed all the way through randomly. So we have some, at the upper tier, lower tier, some at the top of the canopy. We'll even put a couple lower canopy to under, if we're trying to get airflow in the middle, dialed in on the middle of the canopy. Then we graph all of those on our own internal software so that we can visualize what's going on. And with that density and level of data, we can actually start to make changes and see, over the whole room is this, the whole heat map of the room is the average over all these sensors getting to the minimum that this room is capable of doing. And in a multi-tier environment, so much of that is the difference in accounting for the difference between the top of the room and the bottom of the room. So whatever the top tier is seeing versus the lower tier, because in a lot of rooms, heat rises and there's not enough room space, cubic footage at the top of the room to let that heat rise and exhaust it out. I'm sure guys have seen this before.
Michael and I talk about that quite a bit, of increasing the kind of head space above the racking systems for somewhere for that heat to go and air to mix and flow. And we kind of refer to it as not choking a room out in a sense. And it goes back to our conversation around optimization versus maximization. But I always found that quite interesting. I mean, whenever I have a question on sensor accuracy and reliability and density, you're the guy I call. I remember I reached out to you about some airflow sensors last year and we dove down the rabbit hole. And even before that, we had a pretty deep discussion around leaf surface temperature as well, and how there are very few options for these automation and control platforms to actually, factor in leaf temperature to these VPD calculations. I'm a strong proponent of factoring in leaf surface temperature to VPD calculations, specifically for the cannabis crop, just due to the light level and how high the transpiration rate this plant, undergoes. It increases the leaf temperature offset a lot more than other crops that grow at lower light levels, meaning the leaf is a lot cooler than ambient. That difference is a lot greater than many other crops. And you and I have delved into how best to measure that, and you far more than me. I know that you at Zartarian Engineering just came out with a new canopy sensor array with an IR sensor incorporated into it to factor in leaf surface temperature. And it was really cool to see you go through that prototyping process and now finally release the system. Could you tell us a little bit about it? It's pretty cool.
Yeah, sure. It's based off of the LoRaWAN version, like the wireless version that we had as our like private retro commissioning system. So we took a lot of the same sensors and deployed it to a wired sensor that can be the control system's eyes and ears. So
there we go.
Here it is. Let me turn the blur.
Yeah, for those listening, maybe check out the video version of this podcast. You can see this thing in action.
Yeah, and so this is something that is going to be available for the public and not just for your own private use, correct?
Yeah, we're mostly going to go through integrators. Like, it'll be available with different control systems, because this isn't something that you would buy for like your like a pulse meter for like an individual grow. This is very much an industrial product that needs to be integrated. But yeah, for larger systems, we're trying to get as many control integrators to use it as we can. And we're just launching it now. So yeah, it's not large. It's about 6 inches total height, about a few inches wide, so you can get it into the canopy very well. This is our aspirator. So this is actually, it's a 3D printed part with a fan in the bottom of it. That is, by the way, the whole assembly is IP65, meaning it can be sprayed with water, and we actually test it by fogging it with xerotol to make sure it can handle that. So this is the key thing to keep the humidity and temperature readings accurate. And humidity and temperature are the first parts of calculating VPD very accurately. So the fan pulls in air constantly, so this cannot get heated by the lights. We tested under 3000 ppfd so that there's like no chance of it getting heated kind of under standard levels.
Could you
And
explain to people what an aspirated sensor is versus a non-aspirated sensor?
Sure, I think it shows that this is what my mind has been deep in for a long time. So a non-aspirated sensor is where there's no forced airflow through it. You're depending on traditionally with outdoor sensors, you're depending on the wind, or an indoor, you're depending on airflow or something else outside of the sensor to flow air over it so that the air inside the area that's being sensed doesn't heat up by getting, like, for example, if there was no fan in here, this surface heating up and kind of like being a little greenhouse inside of here where the sensor is. Aspirated is where I kind of see it, but there's a fan, and you pull air actively through the assembly to make sure that the air that's coming through there is always what is, what the temperature is right at the canopy versus what it is, heating up inside of the sensor.
Yeah, and it's almost creates like a sample size too, because now you have like a known flow rate and can help get more accurate measurements. Is that correct?
Yeah, and to get real geeky about it, it increases the speed. So if you have of measurements, so if you have a non-aspirated sensor that's not pulling air in, even if it's perfect, right? Let's just call it perfect, and it doesn't heat up. What it does is it takes longer for that air inside here to like the temperature to equalize when there are changes happening. In a cannabis environment, it's very dynamic, like going from daytime to night or night to day. This with it's pulling air in actively, so it sees the temperature changes much faster, which is critical for being able to make changes at the HVAC system and airflow level to then compensate for it and create as little variation in the temperature in the room as possible.
Mm-hmm.
If you look at a lot of control system graphs, you see that sort of like sawtooth pattern where it goes up and down. Maybe it goes up and down 4 degrees no matter what you do. Having a sensor that reads very quickly can make it so you react to that faster, and it can just changing the sensor can cut that in half or more. It's one of the reasons for the aspirator there. It's just and it also keeps the whole thing small. Usually passive ones have to be big. When you see like outdoor sensors that have like the stacked plates, that's called a Henderson shield, and those are great. They're very traditional technology, but yeah, they're big. They have to be big under heavy light, so they take up a lot of space, and they're like shadowing plants. This keeps it small. And then you were talking about IR, so we have a sensor here. Again, like if you look for those, we all just lived through the COVID era where everyone was taking temperatures all the time. That's what's in when you have like a temporal scanner. That's the type of sensor that's in there. So it's non-contact. It has a cone that looks at the leaf and says what temperature, that leaf or that area of leaves is. And that is the only way to calculate leaf VPD. When we have deployed our LoRaWAN sensors, that also had this leaf sensing in it too. And to your point, like what you were saying earlier, we've talked about this a lot. The leaf temperature offset, if you will, is super dynamic through the day. It never stays constant. I mean, you can see the irrigation events through that. You can see, if the plant essentially is happy or unhappy based on its its leaf temperature offset, which keeps changing. So if you're going to use, that's my message, either just use air VPD, which is where you don't take into the leaf temperature account at all, or you have to measure it dynamically with something like this. And we find it, I agree. I think it's super helpful for diagnosing the things going on with the crop to be able to see that in real time. So this This measures at a fairly wide cone, so it averages, you kind of want to aim this at sort of the center of mass of a plant, top of a plant canopy, so it'll take many plants into account, and give you kind of a good, call it spatial average of several plants at the same time, instead of trying to like pinpoint on like one fan leaf that's moving, that could be getting blown around by the wind or growing or whatnot. And then this is adjustable, so you can put it on
it's
the
like a
side of
gooseneck kind of
yeah,
array where you can
exactly.
bend it and point it. Yeah, I mean
So,
that's something I've always wanted in canopy sensors that I've used. I mean, it's leaf surface temperature can be such a valuable parameter when optimizing your cultivation strategy, but doing handheld measurements with a handheld IR sensor can be quite tedious to get a good room average and to get an understanding of what that is. And then it's an instantaneous reading that I can't log 24/7. You know, leaf surface temp can be used for even dialing in irrigation strategy, right? Grodan always says, golden rule of irrigation, transpiration before irrigation. You can watch that leaf temperature start dropping after your lights turn on and automatically start triggering your P1s based off that data. You can just be looking at it, You can do it off your dry backs too, but still, it's just more data to confirm and validate. I think that is so cool that you've integrated that into the sensor and done the testing to feel confident with the data. Um, One thing you texted me the other day that I thought was really interesting. You said one of the best things to come out of COVID-19 is a lot of high quality, low cost IR sensors.
oh yeah, the market is absolutely flooded with every single version of it. This one we have is a medical, is for the medical industry, for non-contact, and you can get them in a variety of different like cone sizes, like meaning like how beamy the
Hmm.
sensing area is. Like, so we have one that is kind of good for sensing it up close, but if you were 20 feet up in a greenhouse, maybe, we'd probably select a different part, and that's easy now. So those parts are now much more readily available than they were before COVID. During COVID, it was pretty difficult to get them. We were like scouring them from all corners of the globe.
Hmm.
But yeah, no, I couldn't agree more. I think once you have real-time leaf surface temperature data, it's really hard to go back, especially for sort of like crop steering style, like rock, you're working with like small rock wool, and doing precise rock wool, or small, precise cocoa irrigation. It's invaluable for figuring that all out. It just gives you another data point to see how, it gives you the most direct feel of like what's actually going on with the plant. Um, is In our LoRaWAN sensors, we also put scales underneath the plants. So we have
Yeah.
we can actually measure the transpiration instead of like with a Teros 12, which is measuring EC and volumetric water content. You can look at just how much does the plant weigh now versus how much did it weigh an hour ago, and that tells you exactly how much water it's transpiring, which is super useful for especially for HVAC system debugging. We like it for plant production, from a grower perspective too. So maybe we'll add that in someday.
Nice. Can we talk about placement a little bit? I know that it's not uncommon for someone to be freaking out about some environmental alert they're getting, and then, you go into the room and you're like, well, yeah, it's literally buried in your canopy. So a lot of people aren't as active with adjusting their sensor placement, as crops are growing. Could be in a mother room, could be in veg, could be in flower during stretch and stuff like that. Is there a best practice, or any advice you have on sensor placement in terms of distance from canopy or anything like that?
Yeah, so not inside the canopy, as you're saying, because it will be more humid inside of there and cooler because of all the transpiration that's going on. So we suggest within 12 inches of the top of the canopy. And this is something, this is cultural too, but especially as folks are trying to get towards more automation, the sensors are your eyes and ears of the grow. And part of growing in this style of being able to automate so many processes is part of that is moving your eyes and ears. And install these with, with the ability to move them with the plants with the plants kind of week by week as they grow to be able to get the best data and best possible to make good automation irrigation decisions. So yeah, between the light and the top of the canopy, within 12 inches of the top of the canopy, generally.
And people need to be expected to move the sensor as plants are growing in various life cycles.
Yeah, exactly. It's part of it. I mean, it's a lot. It's just it's another thing to do, right? But it takes a lot. It doesn't take very long, and it gives you good information. I think culturally, as growers, we're not used to trusting our instrumentation, and
That's fair.
hopefully trying to change that. So I think a lot of people don't look at those instruments as critical because they can't rely on them, and I cannot blame anybody for taking that view over time. But we're trying to change that by having really robust, cannabis focused, like developed for cannabis cultivation instruments, which I don't think there are any of others of those out there. Like we built this for production in racks, high energy density. Of course it can work for other plants too, and in mixed light and greenhouses, but we're really building it for multi-tier cannabis production, and that's where we originally identified the need.
Do you have any suggestions on sensor density for a production facility? Let's say I've heard ranges, for example, of one of these canopy sensors every 250 canopy square feet, give or take. How do you approach sensor density and how many to apply to a space?
Yeah, we've gone all over the place on this. When we're doing our retro commissioning stuff, we put one every 300 canopy square feet. And I'd say that for once you've got the room tuned in, you can kind of walk back to something that's between one every 500 and 1,000. More for multi-tiered environments that have a lot of nooks and crannies, and like you have 3 tiers and 1,000 canopy square foot, or 2,000 canopy square foot room. Like that's a good time for like 6, right? At going at like low density versus you have a large, fairly uniform single level canopy, then you can have less. So yeah, we like to go in and do the sensor layout in the room at the time of design, if possible, and we kind of customize it to the situation based on our experience, knowing how that room is going to perform.
Yeah, I find it interesting where I think it's pretty obvious to most people, the fewer sensors you have, just the less information and insight into your canopy and microclimates and room you have. But there's a downside to having too many as well. I mean, a lot of these systems like HVAC systems are controlled off of an average of all of these sensors. So having them placed in a representative area that will give you the best average of the room than a really accurate single location. I mean, it makes a difference in how that room operates.
Absolutely. And that kind of goes back to like the, commissioning conversation we were having at the beginning, which is that becomes way less critical when the room is evened out and at time of commissioning, so that you don't have that variation, that you don't have to wring your hands over averaging. Ideally, that average isn't getting pushed around too much, and you can almost steer the room HVAC wise off of, 1 or 2 representative sensors and have those as call them the drive sensors, and the other ones as the passengers that are just kind of checking against what those main ones are doing. So yeah, ideally you want it in a perfect world, you could have the HVAC guys want one sensor to operate the room ideally. And then the horticultural folks want as many. So it's trying to stick that balance.
Mm-hmm. Well, Mike, I could probably talk to you for another couple of hours. We might have to have you on for a part 2 of this because I had a bunch of other topics I wanted to bring up with you, but I think we've already been going for an hour. I just wanted to say thank you for coming on the podcast. I really enjoy these conversations. And I would love to continue it on kind of a part 2. For those listening, it's Mike Zartarian Engineering and Precision Ag. What's your website again?
Zartarianengineering.com, all one word.
There you go.
That name wasn't taken already, huh?
No, we didn't have to work. We didn't have to pay. We didn't have to pay too much for it.
Yeah, nice. It's always nice. Well, really appreciate it, Mike. And yeah, I think we'll definitely have to do a part 2. So stay tuned, everyone, and thank you for joining.
Yeah, thanks for having me, guys. It's fun. Anytime.